We already started to discuss linear functions and what are those and what are the important things in them, how to calculate these two important things in any linear function, which are mainly the slope and the intercept. And we discussed that in order to get the slope out of points or graph or table, we need to do the rise over run, which is y2 minus y1 over x2 minus x1. And we've tested those three examples. Then we said we can also count the rise and the run. And if we do that, we just have to check at the end whether this is a positive slope or a negative slope line by using the Nike sign, if you remember. If the line follows the Nike sign, that's a positive slope. If they intersect each other, that's a negative slope. Then we said we solved actually a few examples on finding the slope and or the rate of change. They're both the same thing out of these 6 questions. And then we discussed if we're, instead of points or graph or table, we're given equations. What would the equation look like and what are the forms available there? So there were 3 forms. It's either the slope-intercept form, the point-slope form, or the standard form. The slope-intercept form shows the slope and the intercept, where m here is the slope and b is the y-intercept, while the point-slope form shows a point which has an x and y that are both put in the equation with the opposite signs. And then it also has a slope, which is this number multiplied by the bracket. We also discussed the standard form, and that's one of the most important forms where the x and the y are both on the same side of the equal sign. And we said that the slope is negative the coefficient of x over the coefficient of y. It's negative whatever number next to the x over the number next to the y. We then solved questions on those where we're given a graph and we're asked to find the equation in all 3 forms. We'll also have questions, word problems, where we were asked to find the slope in an indirect way and to find the equation of a line passing through a specific point and has a specific slope. What we are going to discuss today are the parallel and perpendicular lines, which are mainly lines, so therefore they are both linear equations. And then we're going to discuss what we call a system of linear equations, which when we have 2 lines graphed at the same time on the same xy axis, and what are the possible scenarios that could go there. Are you guys ready to do that? Any questions before we start? No. Awesome. Type. So what are parallel lines? What should pop to your mind whenever you read that 2 lines are parallel to each other in the SAT test or the ACT or any of those? So parallel lines should mean right away equal slopes. Whenever you see parallel lines, you think of equal slopes. So how do they use that in the test? So instead of giving you the slope directly and telling you that the slope of the specific line is 3, for example, they would tell you that it is parallel to another line with slope of 3. So instead of being very direct and tell you here's the slope, they'll tell you it's parallel to another line which has the same slope definitely, no matter what. So if, for example, there's this line that has a slope of 3, if there's another line that we were told it's parallel to, the line would have the same slope of 3. On the other hand, if we're talking about the perpendicular lines in your mind should right away reflect into something called negative reciprocal slope. What does that mean, the negative reciprocal slope? It means if I have a line like this one and it has a slope of 3 and another line perpendicular on it this way, this other line will have a slope that is the negative reciprocal, which means you'll flip the 3, make it 1 over 3, and then switch its sign, so negative 1 over 3. So again, what we do is we flip and switch the sign. So if we have a line that has a slope of 2, then the perpendicular would have a slope of negative 1 over 2. if we have a line that has a slope of 2/3, then the perpendicular line would be -3/2. If one has -1/4, the other one would become +4/1, which is 4. Is anything that I've said so far seems to be a bit confusing?
No, it's okay.
Awesome. طيب. Let's see questions right away, but before we do that, let me ask you a quick question and remind you of something. If you were told that there's a line that has a slope of 3 and that it passes through point -2 and 3, how can you find the equation? Can someone guide me through that? Especially if you don't think you know.
Can I try?
Yeah, please.
So I write the formula that y equals nx plus b.
Awesome.
So y is 3
Awesome.
and m is 3 also.
Perfect.
And will be negative 2 and we will continue.
So the b will remain to be an unknown, which then will give me -6.
Greater than 9.
Awesome. So then b is equals to 9. So what's the actual equation? It's y equals 3x plus 9. Perfect. Well done. Meshi. So that's a quick reminder of how to find the equation, okay? Now let's try to check questions. You see 3-4, parallel and perpendicular lines. You see this form here? This is the one that we're supposed to solve. It has a total of 6 questions. They're all about parallel and perpendicular lines. Let me just remind you of something. You need to take note of why is it considered a linear function question in the first place. Like, I want you to understand that your mind is already prepared that this is a linear function. So you're thinking about the linear functions already. But in the test, that's not what's going to happen. So keep in mind, I'll try to highlight in each question, what are the things that would make it trigger to your mind that yes, this is the linear equation, and that would make you think towards that direction. I hope that kind of makes sense. So for the form called 3-4, I'll give you a total of 8 minutes for the 6 questions, and those 8 minutes start now. Good luck. Ah, is there... The way I've read the question now is completely incorrect. You can't and you're not supposed to read the question right away altogether suddenly. It's extremely incorrect and puts you in a situation where you easily get confused. So when we're reading, we highlight again the words that actually matter, the words that we know things about. So when I'm reading, which of the following equations represents a line that is parallel? I'll stop at the word parallel because I know that word, and I know that it should be something related to equal slopes. That's what you should think of. So you think equal slopes to what? What is it parallel to? It's parallel to this line here. So you try right away, before even reading the rest of the question, to get the slope out of this one. What's the slope of this one? It's -1/2. So I know that I have a slope, which is the m, of equals to -1/2. And it also contains the point -2.5. So that's another story. I also have a point now of -2.5. I can actually get the equation using the y equals mx plus b. But if you look at the choices are not in this form. The choices are all written in the form of the standard form of ax plus by equals c. So the easiest thing to do is to check which of the following equations has first the same slope as negative half before I'll even try to check the point. So if you check the first question, or the first choice, it has a slope of negative 1 over negative 2, which is equals to 1 over 2. So that's not the right equation. The second one, though, has a slope of negative 1 over positive 2, and that seems to be the correct equation. If you check the rest, you'll find they have still different slopes. So apparently B must be the correct answer without using this point at all, just using the slope. Does that make sense? Yes or no? And if you have any questions, please ask them.
Makes sense.
Okay, so a few things we've learned in this question, few strategies, not just the math, the strategies of how we started, that's what matters, okay? We started from the words that we know, which is the word parallel. Since it's parallel, we thought of equal slopes. Right after the idea of equal slopes, we thought, what's the slope of that line that's parallel to? It's negative half. We checked the choices, and we figured out through the choices that they're all written in the form of ax plus by equals c. So we found the slopes of all 4 choices, and we figured out that only one of them has the same slope as the one I want. So it must be the correct. Moving on to number 2. Before I start explaining number 2, I want to explain something general regarding the horizontal and vertical lines. So horizontal lines are the lines going kida, like the horizon, going horizontal. So anyway, horizontal line would go something like this. Now, if I said, for example, that this line passes through the point, let's say, negative 3 and 2. Can you guys or any of you tell me what are the coordinates of this point? If you're told that this is 1, 2, 3, 4, 5, 1, 2, can someone tell me what are the coordinates of this point, please?
3, 2.
On the x, it's 3, correct? On the y, it's 2. Okay, can someone guess what's the coordinates of this one then?
Negative 1, 2.
And 2. Okay, so can you notice something now? That all the points on a horizontal line have the same what coordinate? Is it the x or the y?
What?
The y coordinate. The y here is the same as this y is the same as this y. So all horizontal lines will share the same y coordinate, which means that the equation of this line must be that y is always equals to 2. That's the only equation of it. It does not have any x's in it. We don't really care about the x because no matter what's the x value, the y will always remain equals to 2. So all horizontal lines will have y equals whatever y coordinate that's on that line. On the other hand, if we discussed vertical lines like these, if we selected, let's say, this point, and I told you that this point has coordinates of 2 and 3, then the coordinates of any other point on that line will have the same x coordinate but a different y each time. Is that right, or is anyone confused in this idea here?
It's right.
So that means that the equation of this line will always remain x equals 2, and we do not care about the y, it does not have a y, because no matter what's the y value, the x will always remain 2. So again, all horizontal lines, their equation is y equals something. All vertical lines, their equation is x equals something. So when you read question number 2, and it says that there's a line that passes through this and is parallel to the x-axis, that means that this line is a horizontal line. And all horizontal lines have equations of y equals something. What could that number be if that line passes through the point 7 and 6? They must have the same y coordinates. So then the equation is y equals 6, which is D. On the other hand, if you check number 5, it says here it's parallel to the y-axis. That says that it's actually a vertical line, and it passes through the point -5 and 1, which means that its equation must be x equals something, which is definitely the same x coordinate right there as -5. So then the answer here is C. Anyone is confused even for a 1% in any of those two?
No, I understand.
I'll add one more thing regarding vertical and horizontal lines. All lines, or actually all slopes, what is exactly the slope? The slope of a line represents the measure of its steepness. Like it shows how steep the line is. So this is a steep line, and this one is also a steep line. But how much steep is it? That's exactly the slope. Or how much like is it flipped, for example. So I want you to take a look at any of the walls in your house or something, and take a look at any of the pictures or any of the windows in your house, and take a look and think, are these steeped? Are they tilted a bit, or are they straight? So when you look at them, you think, okay, they're straight. But why? Why are these considered straight? Because if you compare them to the ground, they're the same steepness as the ground. They're not, again, they're compared to the ground. So if this is your ground and there's a window somewhere starting here and they're both parallel to each other, then this window is not tilted. But if I have this window going this way, they're not now parallel compared to the ground. So apparently this one will have a slope. This one will have a measure of steepness. Why am I saying this whole story? So that I want you to understand that if a line is a horizontal line, it has zero slope. It's not steeped at all. That's the ground for us. The x-axis is the ground. So if anything is parallel to the x-axis, it's not steeped. Now, the minute it starts moving from left to right, going up, from left to right, going up, this is a positive slope, and it starts increasing. So if this was 0, this would be for example, 0.5, and then 0.7, and then 1, and it keeps increasing until it's totally flipped, where it's now parallel to the y-axis. Now, if a line is parallel to the y-axis, its slope is extremely big because the line is flipped. The slope is huge to the extent that you can't actually define the value. So that's why lines that are parallel to the y-axis have an undefined slope, while the lines that are parallel to the x-axis have zero slope. So there's a huge difference when I say that a line has a slope of 0 and another line has a slope of undefined. An undefined slope means the line is vertical, while a zero slope means that the line is horizontal. Also, that means that if a line has an undefined slope, its equation is supposed to be x equals something, and there's no y. While if a line has a slope of 0, the equation should be y equals something. There's no x. Please give me some sort of a feedback in the chat, like each one of you, whether we can go further or you feel this is confusing a bit. No feedback? Okay, it's okay. Okay, that's good. Thank you. Everyone else, are we good? معلش I like the feedbacks, I'm sorry, but I like to get like instant feedbacks. If you don't have any problems, or if you don't, even if you do, just send me yes or no, we can go forward. Does that make sense? Okay. Mehmet, 50-50. Okay. Amina, 50-50 is nice. So I want you to answer a few things with me, if you don't mind. Like, I want you to tell me, what do you understand? Never mind what I did. Tell me what you understand.
I understand.
Even if it's completely incorrect, it's fine. Just tell me what you know.
I don't remember it.
Okay, take your time.
So you were saying that the slope, when it's tilted,
Okay.
it's a slope, yeah.
Yes.
Right?
So when it's tilted towards which direction? Like, how do we know whether it says it's a positive slope or a negative slope?
If it's tilted downside, it's negative.
Okay.
And if it's up, it's positive.
Interesting. Right? Yes, but then that's completely right. But I want to add one more thing to make it even clearer. How do we know whether it's going up or down? Like, which direction are we moving? Are we moving from left to right or from right to left? Should we read the graph from left to right or right to left?
If it's going from the left to right.
Okay, going up, then it's positive or negative?
If it's going up, it's positive. If
Perfect.
It's going down, it's negative.
Perfect. So that makes perfect sense. So what you said already makes perfect sense. And I just want to add things to the information to make it like stable after. So yes, the line has a slope as long as it's not parallel to the x-axis, it would have a slope. True? Yeah. And as long as it's going from left to right up, it's positive. If it's going from left to right down, it's negative. Perfect. So what if it got to from left to right, it keeps going up? And then what if that line I got to move it even further? Like if I increased its slope, what would happen to the line? What would change in its shape?
The slope will change?
Yes, so it will move. I mean, will it become more vertical or will it become more horizontal?
It will become more vertical.
Vertical, good. So until it reaches this stage where it's completely parallel to the y-axis, correct?
Mm-hmm.
In that case, what's the slope of the line then?
0.
That's not true, because we just said that if the line is parallel to the x-axis, that's when it's 0. So this was 0, and we kept saying that it's increasing. So how would it still again reach 0? It would have to reach a huge number, right?
Yeah.
So what's a huge number?
I don't know.
So what's the biggest number you know?
Maybe 100?
There's 101, so apparently there must be something bigger than 100. What else?
1,000?
1,001, and if it's a million, there's still million and one, and a billion, billion and one. So even if it's an infinity, I can add 1 to infinity. So this means it's a number that can't be defined. It's an undefined number for that reason. So that's why the vertical lines have undefined slope, but not 0 slope. You get the difference now?
Yes.
Okay. That's what I wanted to discuss out of the whole raghi or talking that I said. The other thing that I discussed before that was just these equations of number 2 and 3. Do you understand how did we get these two or not?
Can you repeat again?
Okay, so number 2 and number 3. Do you understand how did you get them? You're not sure, right?
Yes, I understand.
You understand those perfectly. So these were the only two things that I was discussing in this whole discussion. The first part is how to get the equations of vertical or horizontal line, and then how to get the slopes of vertical or horizontal lines. So that's it. You understand them both pretty well and perfectly, I can tell. That's it. Thank you, Amina.
You're welcome.
Now, let's try and check number 4. Number 4, again, I want you to focus on where did I start and why. It says a line passes through the points -1 and 2 and 5 and B and is parallel, so I'll stop at parallel. Whenever I see parallel, I'll think of equal slopes. You see, that's exactly what I do when I'm solving. It's parallel to what? It's parallel to the equation, this equation right here. So what can I get out of that equation? I can get the slope out of it. And since this is the standard form, then the slope is negative the number next to the x over the number next to the y, which would give me 2. So now I have the slope of 2. But then I go back and I check, there are 2 points here. And what do I know about the slope with regards with points as well? I just know y2 minus y1 over x2 minus x1. So if I calculated the slope of these two, it must be equals to this slope here. So I'll say b minus 2 equals to 5 minus -1. That must be equals to 2. Now I have an equation. So when I'm trying to solve, I'm just following basic math operations. B minus 2 will remain as it is, while 5 minus -1 can be simplified to become 6. All is equals to 2. Now, if I need to find B, I need to remove everything next to the B to the other side, which means I need to move the 6 to the other side. So I'll have B minus 2 equals 12, which means that B is equals 14, which then gives me the value of B right away. Does this one make sense? Because I saw a few mistakes there. So are you sure you understand how did we get this answer?
Yes, I understand.
Appreciate it.
Yes.
Perfect. Thank you. Okay. Moving ahead to number 5. These are 2 lines clearly parallel, and since they're parallel, again, I'm thinking about slopes, equal slopes. And since I have a graph, so what do I know about slopes and graphs? I know rise over run, which is mainly y2 minus y1 over x2 minus x1. So I'll do that to the line that has all its points in it. This line L, I'll calculate its slope and I'll say 0 minus 3 over 2 minus 0. That's the slope of L. So what's the slope of the other line, M? It's supposed to be -3 minus B over -1 minus -4. Now, since they said they're parallel, then this means they're supposed to be equal to each other. And that's how I get an equation. Now let's solve the equation. 0 minus 3 is just -3. 2 minus 0 is just 2. All of this is equals to -3 minus b over -4 plus, -1 plus 4 is +3. Now whenever I have fractions that are equal to each other, the only thing I can do is to cross multiply. So I'll say that -3 times 3, which is -9, is supposed to be equals to the 2 multiplied by -3 minus b. Now let's solve that. Distribute the 2. So I'll have -9 equals -6 plus 2b, minus 2b. And then move the -6. So I have -2b equals -9 plus 6, which is -3. That would then give me that b is equals to -3 over -2, which means +3 over 2. If you wrote it as 3 over 2 or if you wrote it as 1.5, they're both correct. And that's it. Please ask if you're not there yet or if you feel like this is too much for me.
So, okay, so I just made a mistake that
Signs.
I forgot to make the lines in the beginning of the so
I was sure that that's the reason why, because I saw your mistake and I saw you
yes.
writing it
I
as
mean,
-3 over 2.
negative 1.5.
Yeah, I saw that. And I thought it's definitely because of the negative signs at the very beginning. So if you notice, the reason why I keep saying the rule while I'm writing it is to make sure that I write the minus and then the coordinates. So it's like, that's why I go with y2 minus and then y1, over x2 minus x. So 1. You get that?
E can't be negative.
Yeah, that's another story طبعا. بس to be honest, I wouldn't as well. يعني in the test, I wouldn't refer back to the graph after I've already got an answer, فاهم? So I get that this is a common mistake. But very, very well done. Let's check number 6 though. Number 6 is very close, the same idea with a tiny trick in the middle, that they're not actually perpendicular, they're not parallel, they're perpendicular. But again, because I read the word perpendicular, I'm thinking of slopes, and I'm thinking of, as I said, negative reciprocal, which means I'll flip and I'll change the sign. So I'm going to get the slope of one of them, which is the one that has all its points, like this one, t. And I'll say y2 minus y1 over x2 minus x1. And I'll calculate that. So 1 plus 3, that's 4, over 2 plus 4, that's 6. Simplified, it's 2 over 3. This is the slope of line T. So what's the slope of line L, which is the other line? I'm supposed to go with y2 minus y1 over x2 minus x1, which then should be negative 6 over a minus negative 1, which is a plus 1. And I'll stop here. This is supposed to be the slope of line L. Now, because they're perpendicular, they're not actually equal. I'm supposed to flip one of them. So that's what I'm going to do. I'll take t and I'll flip and switch the sign. It will become negative 3 over 2. And I'll say these are now supposed to be equals to each other. And I'll do cross multiplication because I have two fractions that are equal. So now negative 12 are supposed to be equal to negative 3, and then I'll open a bracket of a plus 1, and I'll close that bracket. I'll distribute the negative 3, so negative 12 will be equals to negative 3a minus 3. Move the negative 3 to the other side, so negative 9 is equals to negative 3a. A will be then equals to positive 3, and that is the value of a. Please ask. I really wish this to be way more interactive. So we can always discuss, we can just laugh, we can say, I don't understand anything, this is the worst you've ever did, I hate you. Say whatsoever, but make this a discussion. Go ahead.
It's okay to understand.
Perfect. I like that. So
yeah, Mr. Mikhail, I understand.
Awesome. Again, what I care about more than just the steps of what happened on the right side, everything that I've written down is not actually what I care about. What I care about the most is where did I start, and then how the strategy worked. So every question we solve has two pieces in it. A piece that I call timeless piece, and a piece that I call very specific piece. What do I mean by that? So each question has steps in it, steps that are specific only to this question in particular. And there are other things that we did in the question, but that could work on any question related to the same topic, not just this question. The timeless parts are the main idea. The specific parts are the numbers and the calculations, okay? So, for example, in this question, the timeless part is just that the perpendicular would give me negative slopes. That's the timeless part. The specific part are whenever we started calculating the slope using y2 minus y1 of those numbers specifically. That's very limited to this question. Because if this wasn't the case, if this question had a table in it or an equation in it, then the way I get the slope would change. But the strategy would remain the same. Does that make sense?
Yeah.
Awesome.
Yes.
Please, معلش, I know I talk a lot, but these are the things that matter. Wallahi, trust me, you'll see. Rather than just the rules, okay? Anyway. Type, what should we discuss next? We should discuss the system of equations. So whenever we have a an xy axis, just like this one. And let's say we have two lines that are graphed on the same xy axis. For example, here's a line, and then there's another line that's graphed somewhere here. Now, this point of intersection between the two lines is what we call, again, this is what we call point of intersection. And we also call it the solution of the system. Why is it the solution of the system? Because this point satisfies both equations. يعني إيه? What does that mean? It means this point is available on both lines, not just one of them. So this is the point that would solve both problems. That's why it's the solution of the system. So if the two lines intersect, that's great. We do have a solution. But what if the two lines did not intersect? Or what if the two lines actually are the same? What do I mean by that? So imagine if there's this line and then there's another line that's parallel to it. Will they ever intersect? Actually, the definition of parallel lines is that these lines, two lines that would never intersect. So that means there is no solution for the parallel lines. For a system of equations that has two parallel lines, it would have no solution because it would have no point of intersection. While in another case, I could have a line graphed this way, and then the other line is exactly the same line graphed over it. In this case, each point on both lines is considered a solution for the system, which means this case has infinitely many solutions. So there are three cases. If the lines intersect, I'll have one solution, which is the point of intersection. If the lines do not intersect at all, that means they're parallel, which means they have no solution. But if both lines are exactly the same, written or graphed, over each other, that means they have infinitely many solutions because each simple point on any of those two lines is a solution. It works for both. It's available on both. Does this concept make sense? We'll discuss the specifics later. So does the concept make sense?
Yes.
Yes.
Awesome. Okay. So then, in order to find the point of intersection, if we're not given the graph, there are methods to do that. There are two methods to do that, one called substitution and one called elimination. But if the two lines actually have no solution, then there's no point of solving them. So when would two lines have no solution? If they are parallel to each other. In other words, if in any question they told you that there's a system that has no solution, that means the two lines are parallel. And what do we know about parallel lines? What have we learned about parallel lines?
They have the same slope but different y-intercept.
Awesome. So they have the same slope and different y-intercepts. So parallel lines, same slope. No solution, same slope as well. The three terms should reflect on each other. Whenever you read one of them, it should hint to the other one. Now let's start by how to actually find the intersection or the solution. So there's the elimination process. Manish, I'm sorry with the handwriting, I know it's terrible. And there's the substitution process. Okay? We use each of them according to how the graphs are written. The equations are written. If the equation is written in a specific form, it's easier to be solved with one of the methods rather than the other. So I'll show you both and we'll discuss them. Let me take this one system as a good example. Let's take, not this one. If I do that, I'll be solving already the system. Okay. Even though the numbers will be terrible, but yeah, you'll understand the concept. So let's say you have these two lines graphed on the same xy axis and we're trying to find the solution. If we're going to follow the elimination process, then the first step that we have to follow is to make sure they're ordered the same way, which means the x's are right under each other, just like how they're written, and the y's are under each other, how they're written, and the equal signs are under each other, and the numbers are under each other. So that's the first step. The second step is to make sure that the coefficients are equal for either x or y, any of them, okay? So what do I mean by that? I mean these numbers next to the x should be equal, or the numbers next to the y should be equal. So how do I make them equal? By multiplying. So you have to think, what is the number that I could multiply 3 by that would get me 2? And there's no such thing. So what am I going to do is I'm going to multiply this 3 by everything in the upper equation. And I'm going to multiply this 2 by everything in the lower equation. And when I do that, I'll finally have the same I used the stupid example, but anyway, I'll have the same coefficients. So here it goes, 6x plus 9y equals 3. I multiply by everything. 6x again minus 4y equals 2. So now I do have the x's with the same coefficients, which means I should move to step number 3, which is called the elimination process itself. So start eliminating. So ask yourself, how can I eliminate this 6x with this 6x? If I add them or if I subtract them. And if they have the same signs, you subtract them. If they don't have the same signs, if they're different, you add them. Clearly they have the same signs, so I'll subtract. I'll subtract everything up by everything down. 6x minus 6x, they eliminate each other. 9y minus negative 4 will become 13y. And then 3 minus 2 will become just 1, which means that y is equals to 1 over 13. I just got the value of y, which will then take me to the fourth step. Fourth step is to substitute. So if you've got x or y, substitute into any of the equations to get the other variable. By that I mean take this y and substitute it instead of this y over here, for example. So you go with 2x plus 3, and instead of the y, I'll put 1 over 13 equals 1. I'll calculate this on a calculator, which should be 3 over 13 equals 1. I'll move this to the other side, which will give me 2x equals 13 minus 10 over 13, which then gives me x equal divided by 2. Oh god, my mind will blow up at this point. 10 over 26. So I got the x and I got the y. Please ask if you don't understand any of the steps that just happened in the elimination process.
Understand.
Go. Either. Weird. I never thought anyone would understand what I just said. So I think you know it. You've been through it more than once. So I know it's easy because of that. But there are a few things that I've highlighted and talked about when I was moving around, just to make sure that you avoid mistakes and to keep you on track when you're solving the actual question. Okay. Now, in the substitution method, on the other hand, yeah, sorry.
I have a question. So the answer will be, you will put the points 10 over 26 and the y was 1 over 13.
Exactly.
That's the point and the answer.
Yes, but this actually should be simplified very further. This is 5 over 13. So it's 5 over 13 and 1 over 13. That's the answer. It's 1 point that has x and y. Does that make sense? So if for example, this system of equations, if the x represented adults and y represented children, then you just recognize that we have 5 over 13 adults and 1 over 13 children. Come on, that doesn't make any sense. But I mean, in real life context, you just discovered two unknowns that were conditioned by this specific system of equations. Make sense?
Yes.
Awesome. Type. The substitution method, on the other hand, is much better if we have one of the variables already completely alone on one side of the equation. Like, I'll just take this one as an example. Like this one. So here we already have the y equals to everything else. So what we're going to do is to actually substitute. Instead of this y in the other equation, I'll substitute what's equivalent to the y, which is the entire 2x plus 4. So I'll say that x is now minus, and I'll open a bracket, and I'll put the 2x plus 4 inside here, equals to the negative 1. Distribute the negative sign, so I'll have x minus 2x and minus 4 equals to negative 1. Add like terms, so negative x equals to negative 1 plus 4, which means negative x is equals to 3, which means positive x is equals to negative 3. Once you have the x value or the y value, we're going to do the exact same fourth step of the elimination. Substitute in any of the equations to get the other one. So I'll say that now y is equals to 2, and instead of the x, I'll substitute the negative 3. That should give me negative 6 plus 4, which is then the negative 2. And I have now the answer is negative 3 and negative 2. Finally, you can solve any of those by the calculator using mode 5 and then 1. And in that case, you're just going to write the coefficients as 2 and then equal 3 and then equal and then 1 and then equal 3 and then equal negative 2 and then equal and then 1 and then equal. It will give you x and then y. Are we clear about all different methods regarding systems of equations?
Yes.
Yes.
Awesome. Finally, so a system that has no solution and a system that has infinite solutions. So a system that has no solutions means they have equal slopes, different y-intercepts. A system that has infinitely many solutions has also equal slopes, but also equal y-intercepts. So we check first by the slope. If the slopes are different, then they definitely have one solution. If the slopes are the same, it could either be that there's no solution, or it could be infinitely many solutions, depending on the y-intercept. So if they have the same y-intercept, they're the same line, then there are infinitely many solutions. If they have different y-intercepts, then in this case, they have no solution, they're just parallel. Let's check some questions. Solving systems 3-5. Let's start with this one. I don't think we'll have enough time to finish to actually do the others with each other, but hopefully we'll at least get to discuss a couple of questions there as well. So let's try 3-5 systems of equations, and I'll give you 8 minutes for all 6 questions. 8 minutes starts now. Good luck.
ازاي حضرتك؟ انا اسفه جدا، انا يوم الاحد الجاي الاجتماع اتاجل للحد اللي وراه 25، فهل في امكانيه ان احنا نرجع الدرس بتاعنا الحد الجاي في ميعادنا الساعه 6، والحد اللي وراه ال 25 ده اللي نخليه بدال، يعني يبقى يوم التلات بداله؟ انا اسفه جدا، بس يعني حصلت ظروف في المدرسه واضطروا ياجلوا الاجتماع، فهل ده يناسب حضرتك ولا ايه؟ ميرسي حضرتك جدا.
As I said, we've already solved number 1, and we figured out that the answer here is B. Do you want me to redo this one, or is it okay and should we move to the next one right away?
It's okay. We can start from the question.
Starting number 2, you asked to find x plus y. Never mind what you asked, try to find what you know. Whenever I have a system of equations like this one, I'd actually try to solve it easily. And when I look at the coefficients of the y, they have the same number. They're both 1. One is positive and the other one is negative. So in order for them to cancel each other, I actually have to add everything up with everything down. So half plus negative 2 is just negative 3 over 2 x, and then y plus minus y, they'll cross each other. 1 plus 5 will give me 6. I'll move the 2 to the other side, so I'll have negative 3x equals to 12, which means that x is equals to negative 4. Once I have the value of x, I can substitute in any of them to find y. So I'll substitute here. Half multiplied by the negative 4 plus y is equals to 1. Half times negative 4 is just negative 2. Move the negative 2 to the other side, so I'll have y equals to 3. I now have the value of x and y. I just need to add the x plus the y, and that should give me negative 1 as the final answer, because that's what they wanted me to find. Are we clear on this one?
Yes.
Awesome. Mehmet, I think you need to use another email other than the one you're using, because this is an official school email, so you can't log in for that reason. So you just need a Gmail.
Okay. Okay.
I now got to know the reason. At least we know why. Moving to number 3. Now the key word in number 3 is that they said that this system have no solution. So I thought, what do I know about the no solution thing? I know no solution means they're parallel, and parallel means they have same slope. So that's where you're going to think, and that's where you're going to start. If they have the same slope, so let's actually do that. Get the slopes and make them equal. So get the slope of this one, for example, it's negative 5 over negative 2. That must be equal to the slope of this one, which is negative 2 over negative k. All the negatives will cross each other. In order to get the value of k, I'll just cross multiply, and I'll say that k now is equals to these two multiplied by each other, 2 times 2, and then divided by the third number, which is the 5, which would give you then 4 over 5. That is the answer. That is the value of k that would make this system have no solution. Does this make sense? Awesome. Moving on to number 4, the key word here is that the system has infinitely many solutions. When it says infinitely many solutions, then that means I'm supposed to have same slope and same y-intercept as well. So I'll get the slope and the y-intercept of each and check whether they're the same or not. If you check here, the slope is -1/1, while the slope here is -1/1. They're not even the same slope. There is no need to bother with the y-intercept. When you check B, they do have clearly the same slope, actually +2/1, and the other one is +2/1. But for the y-intercept, it's not the same. The y-intercept is 1/1, but this one it's 5/1. So they do not have the same y-intercept, so B is not the correct answer. If you check C, -½ divided by -1/3 is +3/2. If you checked for the second equation, it's -3/-2, which is also +3/2. So they clearly have the same slope. We now just need to check for the y-intercept. So the y-intercept here is 1/-1/3, and the y-intercept here is 6/-2. This one will result to -3, and this one will result to also -3. So they now have the same slope and the same y-intercept, which means they must be the correct answer. Is this one clear? Should we move to the next one?
Yes, Mr.
Appreciate it. Moving to number 5. The key word here is that they said the system has no solution. Because they said no solution, I started to think of equal slopes. And since I thought of equal slopes, I'll calculate the slope of this one, which is -a/-1, and it must be equal to the slope of the other one, which is -1/-b. -a/-1 is just +a. -1/-b is 1/b. Now they need me to find a times b. So I just need to move this b to this side, and it should also go by multiplication anyway. So it's now a times b, and it's equals to 1. So I just got the answer. That's a times b. So in this question, there's no need to find a separately and b separately and then multiply them. I can just find the value of a times b altogether. Is this one clear?
Can you make it again?
Yes, of course. I'll get the slope of each line separately. Why did I think about that? Because they said there's no solution. So once they said there's no solution, that means that the slopes are equal. The slope of this one is negative the coefficient of x over the coefficient of y, while the slope of the other one is the negative coefficient of x over the coefficient of y. And again, since they have no solution, then the slopes must be equal to each other. Now, negatives and negatives will cross each other, and a/1 is just a equals to negative and negative will cross each other, and you'll have just 1/b. When you look at the wanted now, they just want me to find a times b. So all what I need is to put the a and the b next to each other. And to do that, I just need to move b to the other side by multiplication. So I'll have a times b equals to, and what's remaining on this side is just the 1. So that's the value of a times b clearly. Does that make sense?
Yes.
Awesome.
I just checked the equation. I thought A and B should be 1.
Each of
That's
them.
too easy. Yes.
Okay.
I just added it.
And that's perfect. Yes, that's very true as well. So just by looking at the equations, if they must have the same coefficients, then this means this is 1, and this is 1, and this is 1, and this is 1. That's another good note. It makes sense. So what's a times b? It's 1 times 1. It works. That's what we were saying about different perspectives, and I love that we have them already. Checking number 6. if the system of equations مش عارف whatsoever, for what value of A will the system of equations have infinitely many solutions? So that's the key word. Infinitely many solutions means equal slopes and equals y-intercept. So I'll get the slope. The slope of this one is -2 over -12, which is just +4. While the slope of this one is -a over -1/3, which is just 3a. Now these must be equal to each other. So that means that 3a is equals to 4, which then means that a is equals to 4/3, which on a calculator would be 1.3333, which means that this one is the correct answer. Does that make sense?
Yes.
Everyone, are we good?
Yes, Mr.
Okay. Mehmet, I just sent you an invitation to access the account right away. Sorry, the Google Classroom thing right away. So I think you can find it on your email and you'll be able, inshallah, to log in to check.
Okay,
Yes, please check. So you need to go, all of you now, to Google Classroom, please, and actually fill in the exit ticket, which is this one here. Once you're done with the exit ticket, we can leave right away. And please note that the parallel and perpendicular slopes, this form here, along with the word problems, interpreting linear graphs 1 and 2, these are homework and you actually have to solve them. Because if you don't, unfortunately, you're not practicing what we just understood and you forget them right away. So they're the forms called parallel and perpendicular. And they're the one called word problems and interpreting linear functions. What's wrong with me?